Anybody have any questions? I could stop at any time. So,
Move this out of the way.
so I'm hoping you can see something that says fuel gas systems.
Fuel gas.
Yep.
Okay. Like I said, I'll send this out to you.
Huh?
So they're referencing some older codes, but you can see that we're still here. That third one down, IATMO Uniform Plumbing Code coordinated with NFPA 54. So we're still doing that. There haven't been any great big changes with regards to fuel gas. AGA, you may see that on some of the stickers on the appliances. That's the American Gas Association. NFP 50 or 54, I already mentioned. I got all kinds of stuff. So we talked a little bit about sizing, and if you go into the code, there's a section, and then your some of the things we've looked at, but all starts off with what the demand is. Typically, we're talking about BTU per hours. Once we know the BTUs per hour, we can make a conversion over to CFH, which is cubic feet per hour. So natural gas has around 1,100 BTUs per cubic foot. And so if you want to make the conversion, you just take the equipment label, the input. Remember, you don't get 100% efficiency, so the output is going to be somewhat less than the input. And you're also looking at the distance. Gas, air, whatever you're transporting through a pipe is considered to be a fluid. Gas is a very thin fluid, but it has hydraulic properties. So the longer you have to go, the more friction losses you're going to have. And then typically we can either use some complicated engineering formula, or more typically, we just use a simple gas sizing chart. So I think we talked about all of that. So what's a BTU? So that's a British thermal unit. So the amount of heat required to raise 1 pound of water, 1 degree Fahrenheit. So water's a pretty good heat sink.
Yep.
A ton of air conditioning is roughly equivalent to 12,000 BTUs. But like I said, we don't need to look too much at these things. They're in the presentation. If you're interested in that, you can go back and look at it. CFH, cubic feet per hour. So if it said CFM, it would be cubic feet per minute, but normally we're looking at cubic feet per hour. So 1 cubic foot of gas has about, and this is natural gas, about 1,000 BTUs. Hello?
That's natural gas? I thought you said 1,100.
Yeah, it's about 1,100. There's not much difference between 1,100 and 1,000.
That's true. If you tried it for 1,000, you'll never go wrong.
Yeah, that's what I normally do. You know, the gas here locally it's going to vary. Natural gas is in fact a natural product, so the amount of energy per cubic foot varies a tiny bit. So I've seen it around here at about 1,060. For preliminary sizing, I usually use 1,000, and then if I'm right on the edge between a couple of pipe sizes and I'm feeling cheap, then I'll go back and redo the calculations, adjust it from the 1,000 to 1,100, which may push me a couple of cubic feet per hour lower, which if that's going to help with the economics of the problem, I may go ahead and go with that. But generally, That way I don't have to use a calculator. It's real easy. You just move the decimal place. So then we don't care about that right now. Now propane has about 2,500 BTUs of energy per cubic foot. Specific gravity of natural gas, if you look in the sizing tables in the code, it's usually based on a specific gravity of 0.6. Again, the reality is natural gas has some variation. So 0.6 to 0.65, that's still below 1. So what that means is air has a density of 1. The natural gas will rise above the air because it is lighter. So it does dissipate. Propane, on the other hand, is heavier than air, has a specific gravity above 1, and it will sink and collect in low-lying areas. So we've got some code issues related to areas where natural or propane might collect, not the natural gas. Flammability limits, so they're talking about when it'll burn. So if you've got about 3.9% gas in the air, that's the lower flammability limit. So that's when it'll start burning. If you have above 15%, you have too much gas in the air, it's too rich, it won't burn. So, but in between,
it won't burn if you have too much air in it.
now if you have too much gas.
Oh, too much gas. Really?
Right? Yeah, you get above that 15% and it's too rich for combustion.
Wow.
So if you're between 3.9 and 15%, that's where you're liable to get ignition. So, and a cubic foot of natural gas, when you look at this, start wondering where some of those calculations were put together, you need about 10 cubic feet of air in order to efficiently burn a cubic foot of natural gas. The reason that's important is if you get incomplete combustion of the gas, instead of getting carbon dioxide as a byproduct, you get carbon monoxide as a byproduct because there's not enough oxygen. So instead of CO2, you get CO. And the CO is what causes problems. Again, carbon monoxide is odorless, colorless, tasteless. And I think it has a specific gravity above 1 too. So it tends to sink and displace air out of an area.
Has a tendency to suck up the oxygen in your brain too.
Well, it locks up your hemoglobin, so your hemoglobin can't bind with oxygen. So even if they give you oxygen, if you've got enough carbon monoxide in your system, it can't take on oxygen. So there's just some properties, fuel gas properties, if you want them. So just remember they're here in this presentation. If you want to look them up, great. So, and I've never seen any coke oven gas around here, so I wouldn't expect that kind of material. But if you look down there where it says heat of combustion per cubic foot, you can see under natural gas it's 1,000, and under commercial propane it's 2,500. So you get about 2.5 times the bang for the same volume of gas. And then the specific gravity for propane, you can see is 1.52. So it's 50% heavier than air, and that's why it's a sinker. So anyway, I guess that picture's just to wake you up. So you can have problems. So you get enough of it, you can get an explosion. So hopefully you won't have to deal with any of these sorts of things.
I had one before.
So who's been dealing with that?
Me while I'm turning on a water heater, long time ago when I was a teen, it blew up in my face.
Oh, well, I'm glad you're still here.
Yeah.
So, anyway, just some pictures of some problems related to natural gas. I think we had one of our buildings downtown when it was under construction not too long ago. They had an explosion and it tore up some stuff too. So, no, I don't know.
That was the Hilton right by Petco
Yep.
that they were building.
Okay.
That's the one that exploded.
Well,
It was like 10 years ago or like maybe longer than that.
yeah, this may be it.
It's 2008.
Yeah, that was it. Yep.
That may be it. So,
Yeah, I knew guys that were working on that project when it happened.
Me
so
too.
yeah. Well, anyway, one of the reasons that the code takes a pretty hard look at gas installations and why they want permits. So even if you're putting in a water heater and that's a fairly routine operation, because there does exist the potential for something bad to happen, they want to make sure that it gets installed correctly and gets inspected properly.
That house got destroyed.
That looks like Texas. The only thing I can't tell is sometimes in Texas, that's the way the new houses look. Yeah, they're leaning a little bit one way or another. So for buildings, you're usually only going to see low pressure, medium pressure, high pressure. That's for the distribution lines. So out in front of my house, I should have taken some pictures of the markup, but in front of my house, they have a 16-inch high pressure main. So it's 400 PSI. And if you nick that, or if it gets a crack, usually the gas will come out fast enough that it will heat the metal of the pipe to the point where it'll self-ignite.
Wow.
Get supersonic flow out of there. So, and most of the residential stuff, most of the stuff you're dealing with in typical commercial installations is low pressure. So, which is in 5 PSI, not a lot coming. So this is a little schematic showing a pumping station, high pressure on the right there. From the utilities pumping station, PRV is a pressure reducing valve. And then it goes from there, you got medium pressure up to the building, and then it goes to another regulator, pressure reducing valve. And so you're getting very low pressure going into the building. And that's what they want in most cases. Yeah.
And there, I seen a video where they're welding a gas pipe. They put a sleeve on it, so that's why they're talking about it won't ignite because it's heavier than air.
What was this now about the gas pipe and heavier than air?
Yeah, because I seen a video where there was a welder welding a sleeve on a gas pipe because it had a leak. The fire was coming out. They put a sleeve on it and they just welded it up. And then I was surprised. I thought it was going to blow up.
Well, that may be that case where, again, if the fuel air mixture is too rich, which it probably is right at the point where it's coming out of the pipe, you may not be able to get ignition. So it's as it moves away, usually you'll see the flame initiate away from the leak itself because it has to mix enough with the air that it can combust.
Okay.
So I'll have to, if you know where that video is, send me the link. I'll take a look at it.
All right.
Well, we don't need to worry about that. Well, and we already talked about that. So I don't see anything new there. So now pressure, typically gauge pressure, that's above atmospheric pressure, but you'll normally see pressures, low pressures may be quoted at inches of water column. There's also pressure that's indicated as inches of mercury, but mercury is much denser than water, so you'll have fewer inches of mercury versus water for the same true pressure. But this just gives you an idea of what you're dealing with. So one PSI, you can see 28 inches of water column. So, and that's because we have that 0.43 PSI per foot of water elevation. And so 28 inches is a little over 2 feet. So that 0.43 per foot, you multiply that by 0.43 by a little over 2, you're going to come up with 1 PSI. So that's where those numbers come from. A picture of a pressure regulator, and I think we've got a little schematic on how they work. So just showing some of the parts. Inlet pressure, the higher pressure on the left-hand side, the appliance pressure, which is reduced on the right-hand side. Got a little diaphragm above there that's controlled by a spring. You can see that seal cap can come off so that that adjustment screw can be accessed. That's kind of that vent limiter, that's kind of a blow-off valve in case the diaphragm ruptures. Occasionally those things will fail. And if it fails, what they want is they want the gas to get vented outside normally rather than be pushed into the building where it can do some real damage. Oh, yeah. So. Guess I should put in all the parts. Talk about the odorant. I thought this was pretty interesting. I hadn't looked at this in a while. So I was looking at it not too long ago, and I'd forgotten that in Vegas, at the Mirage Casino, they had this gas that they were using for special effects for their volcano when it erupted. But they didn't want the smell of rotten eggs in their gas, so they put in a scrubber that replaced the rotten egg smell with pina colada odor. So, who knew?
That's pretty good.
Yeah.
That's pretty funny.
So, yeah. So anyway, but mercaptan is what they typically use, but that's hydrogen sulfide. So that's the same thing that you find in sewer, the stinky stuff in sewer gas. A lot of it is hydrogen sulfide. But again, if you're exposed to it for an extended period of time, you quit getting the sensation of the smell unless you leave the area and then come back again. I'll just bring them all up. So these are natural gas pipe materials from the code. So cast iron is not recommended or allowed on fuel gas piping one time, or if you're in an older city, you might run across some. Black steel, ASME stands for American Society of Mechanical Engineers, and ASTM used to be American Society of Testing and Materials, but they now call themselves ASTM International, and those A106 and A53, those are standards that they publish The ones from ASME, usually if they have an M after them, that means that it's a metric publication. PE or polyethylene, you can see underground outside the building where approved. The corrugated stainless steel tubing, which we've talked about. ANSI is American National Standards Institute. And AGA, we already said, is American Gas Association. Copper, and it says copper could be problematic if you have much hydrogen sulfide in the gas itself, which is possible depending on what field they pull it out of, because every oil field is different, because whatever animals and plants died to create that oil, there's a different batch and under different conditions at different times. So every oil field has slightly different petroleum products, some cleaner than others. Yeah, so that high pressure stuff, that's where you see the Schedule Schedule 80 or 160. You see, I don't know if you've ever seen any Schedule 160 pipe. It's just a solid piece of a pipe almost with a little tiny hole through it. Schedule 40 is the thinnest wall. Schedule 80 has considerably thicker walls, and Schedule 160 has much thicker walls. So, but to deal with the high pressure, you need more pipe, and that's how they get it. I talk a little bit about the stainless steel clearances, protection against damage, warning tape and wires. So all of this is pretty standard and in the code for all the materials we're using if we bury them. So with plastic, we have other issues. We need to keep the plastic typically away from a heat source, because heat will soften the plastic, or in some cases melt it. So, and right there, what they're showing is you either need a pipe that's strong enough or dirt that's been bridged in some way. So what they're showing on the left under that, what's supposed to be a vehicle tire, I think, is a pipe sleeve. And so if we're going to use a sleeve, the sleeve needs to be large enough that it actually provides some protection around the pipe. So if there's some movement there, it shouldn't impinge on the pipe itself. Burial depth, I think there's some more stuff in here, but so if you're running a rototiller or a ditch witch or something like that, if you know you're going to be doing that at some point, it makes sense to bury the pipe deep enough to miss what you're ordinarily going to use. But again, people can always go above and beyond. And I've seen a couple of gas lines ripped up or damaged. So it can get pretty exciting. Tracer wire, normally I see the tracer wire wound around the pipe rather than being above the pipe, but they're showing it above in this particular picture. And then the caution tape, so that's just looks like that yellow tape that you see run around the buildings, or maybe a different color in some cases, but the plastic I see being used, the polyethylene, all of that I've seen has been yellow pipe. So there are other colors of polyethylene that you'll see out in the field, but they're normally used for something else. So, and we already mentioned that the purpose of the tracer wire is you can put electric current in there, generate a magnetic field, and then with the magnetic field detectors, you can figure out where that pipe is, rather than digging it up yourself. So I don't know if anybody here has ever gone looking for a buried pipe. I have.
I have.
So my yard looked like that that place from the movie Holes, if you've ever seen that. And
Yeah,
just holes,
everywhere.
holes everywhere. So anyway, I'm sure I told you the story about trying to prop up my fence. Went and bought a steel stake, hit it twice with a hammer, found the pipe I was looking for, had a fountain.
You had a fountain?
Had a fountain. Yeah, I was looking for the water line coming into the house, and eventually I found it. So
Dig alert, dig alert.
yeah, dig alert. So we talked about dig alert, and one problem I noticed, at least the last time I went to the dig alert website, because of COVID, they're not sending out all their free stuff right now.
No.
Because they used to give out some pretty good free stuff. And I should look at Oregon's, because up in Oregon, you could get a discount on having custom printed t-shirts. But I'll have to get back into that later. Anyway, underground pipe installations. They're just showing some schematics. Normally, you should have, like I said, that tracer wire. Normally for residential installations, it's wrapped around the pipe, it's coiled around the pipe. And caution tape normally is supposed to be about a foot above where the pipe is. SDG&E, if you're working off-site or off-property in one of their trenches, typically they require a silica sand, a white shading sand, so that once you get into that, it's very obvious that you're into an alien or foreign material.
Can you move your gun from the
Yeah, here it doesn't get cold, it doesn't freeze. So, but the ferrous piping, you need protection against corrosion. Typically, that means it's wrapped with an asphalt coating. Here locally, we normally don't bury ferrous metal gas piping in the ground anyways, just because we have problems. SDG&E does, but they spend a lot of money protecting it. They also usually have some sort of system in place to protect the pipes electrically. So they'll put in some galvanic sacrificial anodes, and somebody has to keep track of that. As far as I know, we don't have much water in the natural gas here locally, so we don't get cold enough that freezing might be a problem. But if you have a sag or a low spot in the pipe and you had water there, you could get some freezing. There's that picture we were looking at last time, I think, that sediment trap.
Oh, yeah.
And so,
Dirt leg.
yeah, that's just been pulled out of NFPA 54. You can see lower right-hand corner, which is why it's in the code. So you got the cap on the bottom that can be screwed off. You got the 3-inch nipple and the T-fitting. The whole idea is the gas should come down and have to make a right-hand turn. That way the sludge, water, whatever, should drop down into that nipple area. And then periodically, somebody should take the cap off and clean it out. My guess is that happens about how often? Never.
0.
So most people don't do maintenance. You'd have to turn off the gas. So, although we should, if it's on an appliance, we should have a shut off there, right there in the room with the appliance. It's not too far away, but still. So that sediment trap is supposed to be after the appliance shut off. Earthquake valve. So from time to time, they've tried to get this made as a mandatory requirement in the plumbing and mechanical code. SDG&E has fought that because one of the problems they have is After an earthquake, they get all kinds of calls. And what they don't want to have to do is usually there's not much damage. And if everybody has an earthquake valve and all of their gas supplies get shut off, rather than taking care of emergencies, they'll be getting these demanding calls to come turn the gas back on. So far they haven't done that. Some jurisdictions, though, do require that shut off, particularly in places like restaurants where you have a gas cooking line, and they'll require a shut-off valve. There's a number of different types. Some are horizontal, some are vertical. So it depends on the position they're going to be installed. So in this particular slide, you can see on the left, that's just the valve itself. And then on the right is the valve installed. So they got a piece of, it's like B-line or unistrut that they're anchoring to. You've got the regulator over there on the left and the gas meter. And the importance of the gas meter is that's where SDG&E gets their money. So in the newer ones, they've got smart meters just as they do for the electric. So they don't have to send a reader out for them. I don't see anything right there. So gas pipe through the foundation wall below grade is not allowed in most areas. And so that's why you see that from the street main to the meter, usually it comes up and then it should enter the building above ground. The concern is if it comes in underground, there's a leak. There's a possibility of gas collecting underneath the building or seeping into the building, and because it's lighter than air, collecting in there and causing some problems later. And where you go through a foundation, again, it's required to be sleeved. That's what they're trying to show you on that picture on the right-hand side. That's supposedly a symbol for dirt. The thick black circle, that's supposed to be the gas line. The light circle, that's supposed to be the sleeve, but they could have drawn that a little better, I think. Now, this is what it should look like. We're coming up and then coming off the meter and going through above grade. So the horizontal line you see just below the M, which stands for meter, is the supposedly the grade. And again, they want to seal that sleeve that it comes through. So they're going to put something in there. The concern is always if you get a leak, they don't want it getting into the building if at all possible. They did have a case here in San Diego where somebody had a leak at the meter, and the backfill in the trench up to the house was filled with gravel. And so that gas was able to travel through that gravel and get under and into the house. And somebody flipped on a light switch. Fuel air mixture was in the right zone, and they had a little explosion in the house. So we talked a little bit about bonding the gas lines, and so they talk about that here. We don't need to go through all of that, but this covers it pretty well. This is for, again, CSST stands for?
Corrugated stainless steel.
Either that or commercial supersonic transport. So, but, and you can see in the red down there, it says, arcing from lightning strikes has been known to blow holes in an ungrounded corrugated stainless steel tube fuel gas lines causing leaks and fire. So we don't have much in the way of lightning around here, but some parts of the country they do. So I talk a little bit about lightning. So they list some states there that have plenty of lightning strikes. Florida, I believe, has more lightning strikes than any other state, which is probably not surprising considering their weather patterns. But, and then if you're interested in a lightning protection system, right, we've got another NFP that's listed down at the bottom, NFPA 780, standard for the installation of lightning protection system. If you deal with airport control towers, they have a pretty elaborate lightning protection system because of all the electronics in the control tower. They want to make sure that that's not impacted by a lightning strike. So regardless of where they're located, they always have protection against lightning strikes. Yeah, so wherever you have two different types of metal coming together, so this occurs typically at the water heater tube. Also, for the gas pipe transitions, you normally need a dielectric union. So the code doesn't want two dissimilar metals to come into direct contact, particularly in the presence of any kind of moisture. You get a galvanic cell going, and one of the pipes will corrode or collect material, and the other pipe will get eaten away. So,
That what happened when you also got too close to the foundation.
yeah. So, and what happens is we've got, it's a two-piece metal gizmo, and then they put there's a rubber washer in the middle that acts as the actual dielectric to keep electricity from flowing across that boundary interface. The washer acts as an insulator. This is all National Electric Code. We've covered, the bonding. So regardless of what any of the national or state codes say, the authority having jurisdictions, your local building department, you're normally going to have to do whatever they're in the mood for you to do if you want to get approval. So depending on specific practice or experience at the building department, they may have some slightly different requirements. And you should always look into that. Did I ever send out those electric newsletters? I can't remember.
I don't think so.
Well, I'll send them out tonight. And if you've already got one, well, you don't have to read both. This is just some of the fittings for the CSST. That's some manifolds over there on the right. So more typical layout. This is kind of the pecs of gas piping. So here's one where we're coming off the meter. They take it to a manifold. And then from the manifold, they're running the pipes from the manifold to the appliances. That looks very similar. Just some commercial stuff. Here's one where we have the house line regulator, and then the manifold is coming immediately after. So the union right there, that's the dielectric, that's code required. Looks like a ball valve over there on the the left-hand side. So you see the 5 PSI coming in. You see the little handle there next to the left of cap. That is the shut-off valve. You've got your drip leg sediment trap. IP, I'm sure, stands for inlet pressure. OP for outlet pressure. No. So now there are some prohibited locations for gas pipe. So those are listed here. And I guess the reason for that is they're trying to avoid the boom. So that's the concern always. So gas is toxic, or can be. Leaks in concealed locations, though. If you have a slow leak, it can collect and if it reaches the right fuel air mixture and it finds an ignition source, you're going to have a boom, and usually that's not good. So when the inspector comes out and they're checking the connections or they're checking the pipe, a lot of times they're just coming out with a spray bottle with some soapy water in there. They'll spray that on the pipe. And if they're getting little air bubbles coming out or little gas bubbles, then they know that there's not a good seal. Now, sometimes people will use things like pipe dope where they shouldn't. And I don't know if I mentioned in my house, I smelled gas in my kitchen when I first moved in. And I couldn't quite figure out exactly where it was coming from. Finally, I pulled the range out, took the flexible connector off, and found out that they had used pipe dope on that little semi-hemispherical fitting, because that's a little brass fitting that they use in there, and that really relies on the close mating of the brass surfaces to give the seal. And somebody put some pipe dope in there so that the connection could not tighten properly. So read the instructions.
Wow.
Yeah. So anyway.
They put it on a compression fitting? Not just not the threads?
Fitting. No, what not? Yeah, it was. It was just the screw-on, standard screw-on fitting. If you look inside, that's kind of a machine face.
Yeah.
It's supposed to, when you tighten it up, the brass will deform a little bit, and you're supposed to get a nice tight seal that way. But they put that plumber's putty in there, and
nice.
So there was no way to completely seat it.
Yep.
Anyway, concealed locations. You should have a casing or a chase for solid walls. They say they don't want any joints or connections because those are places where things would leak. And if they're in a concealed location, you can't get to them for maintenance easily. They don't want any compression couplings. They don't want any bushings. A swing joint, that's typically where you put a bunch of 90 degrees and pieces of pipe together so that if there's some movement, the pipe itself can move or swing. And they do have an exception of brazed tubing. And so brazing is done at a higher temperature than soldering, but a lower temperature normally than welding. But and then if the fittings are listed for a concealed location, that would be an exception. So.
With a match?
I've seen people do that. They have. They're
that's funny.
they have some, what are they, PIDs? No, there's a photo ionization detector, but the health department out at the dump, they have some, and what it does is it samples the air and actually has a little spark in there to see if you have some combustible. So And the one thing it does say, if you're using soap, you should be using a soap that's non-corrosive. So you should verify that it's okay. Gas detectors, there's a variety of gas detectors. Beep, beep.
Burp, burp.
I don't know what that is. No, we don't care about that too much. Just some things on the gas valves. So I'll let you read that.
Oh, that's a good one.
It appears that somebody had a minor problem.
What happened there, Larry?
Well,
Dryer.
Somebody was welding.
yeah,
Are you sure? That looks like it was appliance or something.
yeah, they had some sort of a problem. I don't know exactly.
Looks like there was a dryer there or something.
Yeah.
Mm-hmm.
With the vent.
Yeah. Agree.
You know, these are, it's not unusual. I've been, uh-oh.
Uh-oh.
Sounds like we have a new instructor. And they appear to be more articulate than I am also. Great. Anyway. So a little gauge, checking the pressure. There it looks like they're using some soapy liquid. And that's what you get is the gas bubble. So I've been out on, I don't know how many inspections, but it is not unusual to see something exactly like that when you go out on a gas inspection. And so you may not be able to smell the gas. You may not be able to detect that anything is going on. It looks like they're using Teflon tape there. There is a Teflon tape that's approved for gas lines, for threaded gas lines. And you need to read the instructions. It's, I think the stuff I've seen is yellow in color, but you don't want to use the Teflon tape that they specify for water lines because it's not listed or approved for that particular use. And you want to look at the fittings too, because in some cases that may be prohibited. But it's in the plumbing aisle right there next to the regular Teflon tape. I know what to do. And again, this is more design issues, so this is beyond the scope of what we're doing, but this thing is fairly complete, so I'm going to send you the whole thing because, believe it or not, we're exactly halfway through this presentation.
Wow.
And I'm not going to take you all the way through it because we
Oh,
don't
that's a lot of pages.
need to. So now this is outside, and if it's facing a parking lot, then you need to put something up like that bollard on the right, that concrete field steel post, so you don't have people banging into it. And again, you have to decide what's going to be adequate for the particular condition involved. So SDG&E may also have some input into what kind of protection the piping has. So when I had put my gas meter in, it was close to the driveway. They made me put in two 4-inch diameter concrete filled steel pipes. And I forget exactly how far apart, but that was just to protect one little residential meter. So anyway, there's some nice pictures in here. Take a look at all that stuff. So. Happy days. So down in the lower right, I don't know what that comes from or where it goes to, but that looks like some of that corrugated steel tubing. Although it looks open, so I don't know if, I doubt if it's attached to anything. It looks like it's just loose.
Going to the building.
So we looked at that. Am I going backwards? No. Some stuff on kitchen hoods, and we'll be talking about kitchen hoods and the mechanical code a little bit. And I've got a handout for you on hoods. We saw that picture. These are just schematics. So if you want to know, the graphic symbols for valves are shown there. Not unusual to have rooftop units. And again, this is the typical kind of stuff I see that's normally not permitted by code. If you look at that rooftop piping, they show a couple of blocks or a couple of bricks underneath the piping. If this was a school or a hospital, you'd have to anchor those pipes, and there would be some sort of design for that. So that piece of equipment is sitting on a curb, looks like. And again, the curbs have to be anchored because the last thing they want is, they don't want this stuff shifting around during an earthquake where you may damage that gas piping and perhaps initiate a catastrophe. Yeah, we looked at that. You can look at that, so. So that looks good. Again, that's usually the sign of a well-maintained facility.
What happened to it?
Well, it says it's a high efficiency
Corroded.
condensing unit. So if you've got a condensing unit, you're going to have water being forced out of the air. And if you get water in contact with metal, then usually in the presence of oxygen,
Oh, it's rusting.
bad things happen. So that's what's happening. It's
I
just
couldn't tell that was rust because it looks like it just fell apart.
yeah. But I'll send you the whole thing.
Okay, cool.
Nice.
We'll be looking at some of this stuff anyway, combustion air, which we have not talked about, but we will. So I will, oh yeah, we're about there anyway. So it says stop here. So we will, oh,
Hey, what happened to the pretty pictures?
I turned them off. I'm sorry about that.
Wow.
One thing I have noticed since I've been instructing this way, I didn't realize quite how hideous I had become.
What does that mean?
Wow.
You know? So, but I have been able to make a couple of posters and send them out for parents to scare their kids with. So that's been a benefit.
I'll take two.
That's funny, Larry.
Anyway, anybody have any questions on anything?
No.